methods of improving string efficiency. From the previous lecture session, we have discussed about the string efficiency, what is string efficiency, and these kind of things. And what is the expression of string efficiency, what is the voltage distribution across the string, and the different discs across the string. So now we have a few idea that how the string efficiency hampered due to the aim, uh, the constant aim or other parameters, but now we'll discuss those parameter in detail. So methods of improving string efficiency. So we have three methods. Okay, the first one is the by using longer cross arm. Okay, second is by grading the insulator, and the third one, sorry, by grading the insulator, and the third one by using guttering. So one by one we will discuss these things. The first of all we will discuss by using longer cross arm. What is that? We know that this is with the ground, the tower is connected, and this part is the cross arm. So if we with the cross arm, the insulators are connected, right? Insulators are connected, and the C1 comes between this tower to the metallic part of the insulator. Okay, so this is C1, right? This is C1. Now we know that the capacitance varies, okay, or depends upon the distance between the disc. Okay, this this is the ground and this is your metallic point, let P. So if we define this thing as this is one disc having ground potential, and let this is another disc of the capacitor denoted by P having some potential. Okay, so having some potential. Okay, so this is the distance between these two discs denoted by small d. So whatever is the capacitance arises here, let for example having a capacitance C dashed, then if we increase the distance between this ground disc and the P disc, ground disc and the P discs, okay, by this distance. Okay, so now the distance between these two discs increased. So what is the distance? This one, let this is d dashed. Then what will happen? Whatever is the capacitance arises for the second case, that drops, defined as d double dash, that is actually less than c dashed. Okay, that is actually less than c dashed. Okay, I repeat this part. So c dashed, or you can say c dashed is greater than c double dash. So c double dash is the capacitance with the longer disc distance or plate distance, whereas c dashed is the shorter distance between the plates having shorter distance. So obviously, so if we increase the cross arm, so cross arm increases in this way, so then the discs are placed here. So then what will happen? With the tower, the P point now shifts from this to this way. So obviously the distance increases means what happens? The capacitance drops. Okay, so and this capacitance is basically C1. So C1 drops. Okay, right? This is the thing. So by using longer cross arm, the first point mentioned here, string efficiency depends upon obviously this small m, and that equal to C1 divided by C. So in this mechanism, by increasing the cross arm, we can control the value of C1. So if the C1 drops, so obviously M drops, right? Okay. So the second point, lesser the value of M, greater the value of string efficiency, and more uniform the voltage distribution. Okay. So cross arm, increment of cross arm length, increase of the cross arm or cross arm length, that drops C1, that drops M. that drops M. Okay. Now we cannot increase this cross arm as according to our wish. We cannot increase the cross arm according to our wish, that we want to increase the cross arm more longer, more longer. That is not possible. First thing, that is not mechanically stable. Okay, it may happen na to we want to increase the cross arm in such a way that that is almost equal or more than the height of that earth. That is not possible. Mechanically that becomes unstable. So if you, and also the cost, if we increase the length, so obviously more and more material is required, and obviously increases the cost. So this is the point that is mentioned, limitation of cost. Obviously you have to think about the price or cost involved, and the strength of the tower, mechanical strength. Okay, so the system becomes unstable, the physical system becomes unstable. So the strength of the tower do not allow the use of very long cross arm. Okay, so there is the physically there is some limitations. Okay, the length should be uh, managed in such a way, the tower length or the cross arm length in such a way that that is actually uh, financially feasible as well as mechanically feasible. Okay, so therefore in practice M equal to 0.1 can be achieved by this method. So M can be 0.1. Okay, in practical method. So in our previous example also, so look, with our example we have discussed with M equal to 0.2, and we have this V2 value and V3 value. Now if people can put the value of M equal to 0.1, so then check putting this value, please check the voltage difference between V2 and V3, V1 and V2, this way. Okay, so it will observe that the difference between V1 and V3, for this case let V3 minus of Vt, whatever is the voltage for M equal to 2, whatever is the value, if we put the M equal to 0.1, we'll see that the difference between V3 and V2 will be lesser. Okay, so this way string efficiency can be improved. Okay, so differences decrease means we have better string efficiency. You just put all these values in this expression, you will understand the thing. Okay, the next is by using guard ring.